Now, welcome to Wi-Fi troubleshooting tips and tricks. It's a great episode that we got lined up for you today. I'm going to pass. I'm your sidekick, Stu, and so I'm going to pass it off over to our great hosts here, Matt and Mac. Matt, why don't you take it away?
Thank you very much, Stu. And yes, very quick introduction. So you've got myself and Mac here, both directors of product marketing and ECSE. And like you just said, Stu, our favorite psychic, Stu. And actually, we are talking about one of our favorite topics today, which is troubleshooting and Wi-Fi. So yeah, we're going to be, going over some really great theory with you about some of the things we need to watch out for when it comes to troubleshooting Wi-Fi. And then we've got a really great demo lined up for you later on in the show today, where we're going to put all of that great theory that we just covered in the first half of the webinar into a really cool demo with AI Pro towards the end of the webinar. So we're really excited to get kicked off and going. And without further ado, then let's discuss a couple of different approaches to troubleshooting. So we have two types of troubleshooting, we would say, and you have the reactive type of troubleshooting and the proactive. And what is the reactive type of troubleshooting like? And I'm sure we have all been there before, where you're sitting at your desk in front of your computer, you think life's all good, it's all great, and all of a sudden you get an email pop up, or a ticket has come in, or someone starts ringing your phone. Oh my gosh, Matt, the Wi-Fi is not working. The CEO, he's coming into the office today and he needs to be able to make this call to speak to this new big customer deal that we've got going on. You need to get down here now and fix this problem. I don't know if any of you have been in that kind of situation before, but it's certainly happened to me a few times. And it's not a nice feeling where you have that sinking feeling into your stomach and you're kind of feeling like, I'm just trying to put out fires left, right, and center. It's not really a nice way to start your day if you've got to go drinking your morning coffee and you're getting all of these different alerts coming in and different problems that are happening because people have made some changes in the environment or something else has happened and you just wasn't aware of. And yeah, it wasn't quite the best start to the day. I can see you're smiling there, Matt, because we know we've both been in that situation a few times before, right?
Well, speak for yourself. I'm the proactive guy, not like you.
All right, what's the proactive approach then, Mac?
So the proactive approach is actually the troubleshooting approach is not just troubleshooting, it's a lifestyle. So whatever you do in life, you do in your networks as well. So I like to stay on top of my things all the time without having to react. I want to make sure that my network is spotless every single day. So proactive approach, it means that you are constantly monitoring your network and you spot the issues before they become a massive major outages, before your users start screaming at you and disturbing your very important morning coffee, of course. So proactive monitoring is not only monitoring using your monitoring tools that monitor your network devices and monitoring your stats. You also need to monitor the physical side of Wi-Fi, and that would be periodic health check surveys. You want to walk around quite often around your site, making sure that everything is in tip-top condition, because very often you won't be notified as a Wi-Fi team about building new walls or removing old walls or changes in Teams, how people see it, where they see it, how many desks they use, what applications they use. You might not be notified about it. And without understanding everything about your network from a physical perspective, so by doing a physical validation survey, you wouldn't know about those things. New interferers, you wouldn't know about them either. So I like to perform all of that quite often and stay on top of things.
So what you're basically trying to say is, I'm like the guy on the left, very reactive, thinking everything's fine, trying to put out fires everywhere, and Max, the cool dude on the right, thinking, proactive, everything is fine. He's just nice and calm, relaxed, and skateboarding around with his nice, cool new sidekick too. So is that what you're trying to say, yeah, Mac?
Absolutely. Even look at the graphics. You can see like one guy on the left-hand side without any facial hair, with nicely done hair. Like, it resembles Matt a little bit. He always wears like a nice polos and he generally looks very smart. So he needs to look better because he's not working too well by doing a reactive troubleshooting. Whereas I can just relax, I can sip my coffee, I can have my sidekick, I can just ride the skateboard all day long because I always have everything under control. And that's the person I hope that you would like to be.
Yeah, I think everyone should be a bit more like Mac. And how do we be a bit more like Mac then? And that's making sure that we are, following our 3 steps to great Wi-Fi every day, and doing the really key, really important part of your Wi-Fi life cycle, and making sure you're doing the regular health check surveys. This is the best way you can keep your finger on the pulse of your Wi-Fi network and ensure that they stay high performing. Mac had a great example that no one really notifies the network or the Wi-Fi team if they make some physical changes in the environment, ripping down walls, changing the shelving in warehouses, and reconfiguration of the office, different event spaces at different times. You normally notify the Wi-Fi engineers, but things like this can have a massive impact to the performance of the Wi-Fi. And if you're in a multi-tenanted building as well, and then you can hear the adjacent floors Wi-Fi networks, perhaps they start using some different channels, which start to cause a lot of interference on the network, on your network, or bring in some interferers. And the best way you can track and locate them and then reconfigure your network to make sure it's staying optimal and high performing is by doing these health check surveys. So we can't stress how important these are. Get like Mac and a bit like Val the validator with the regular health check surveys.
Totally. So let the poll read the poll, shall we? What is your first approach to troubleshooting, my friends? And option A is doing an assessment survey. Option B, doing a Wi-Fi scan. C, doing a packet capture. Or D, doing spectrum analysis. Also, there is another option, I think it's called turning it off and on again, but I'm not sure if you want to go there.
No, I'm really interested to see what different people's approaches here for their first thing to troubleshooting. That first moment of panic when you go on site and someone says, oh, we need you to come and troubleshoot the Wi-Fi. It needs to be fixed within 1 hour. We've got this huge deal, big happening, and it needs to be working again. What's the very first thing you do? Do you go and do a survey? Do you to check what's going on with the coverage and channel interference? Do you just quickly pull out your analyzer app and Sidekick and do a quick Wi-Fi scan and just see what's going on in the environment? Are you the type that likes to use a packet capture, so using the capture app and then have a quick look at some of the frames in the protocol and analyzer? Or do you want to think that you can just quickly have a quick peek into the spectrum? Have I got any interference here? Layer 1 interference causing me some issues. So what I'm going to do now is end the poll and then share the results. We can take a look at what everybody thought. So really interesting. It's very, very close actually between the top two. So 39% for assessment survey and then 37% for a quick Wi-Fi scan. Interesting.
Well, this is not actually, I was expecting to see something like that. The first 2 options being the most popular because they are the fastest, right? You do an assessment survey, you grab your Sidekick, you connect it to your mobile device, you walk around the site, and then you quickly validate what you've seen. Or you take your Ekahau analyzer app, connect the Sidekick to a mobile device, and have a quick glance at what's happening in your network. Whereas I think Peter Mackenzie would be massively disappointed because packet capture grabbed just 8%. And I can't blame you, my friends, because packet capture is a little bit more complicated. You need to understand how protocol works. You need to know exactly how it should look like in order for you to find an anomaly. It's an extremely powerful way to look at things, but yeah, I totally get it. And spectrum analysis, also not too popular. I'm actually quite surprised with spectrum analysis not being a little bit more popular, because how can you spot non-Wi-Fi issues without spectrum analyzer? It might be quite difficult. So I probably would vote that a little bit higher, but generally, I agree. How about you, Matt?
I kind of agree. I thought the most popular one was going to be doing the assessment survey, and then I did think Wi-Fi scan would probably be up there. And then between packet capture and spectrum analysis, yeah, I thought it might be a bit of a tight, close call there. But very interesting results indeed. So let's take a look at some of those approaches in a little bit more detail. So we got that first one then. So from our troubleshooting tools, we are talking about the assessment survey. So this is when you're going to be grabbing your mobile device, maybe the survey app, or if you're going to be doing it with your laptop and AI Pro with your trusty Sidekick 2, and you're going to do a quick walk of the environment, measure everything that's going on with Wi-Fi, and then you're going to analyze that data and then see if you can work out, is it because I've got coverage problems? Is it channel problems? My signal to noise ratio? What's not looking quite right here? And then that protocol analyze the tool we were talking about there is where you're going to be using your Sidekick to capture those wireless frames that are happening over the air for a period of time. And then you're going to chuck them into one of your favorite protocol analyzers and take a peek into the captures and frames and see if you can spot any anomalies there that could be causing some of the problems. Is it into the configuration? Is it the client devices capabilities that's causing us these problems? But again, you know, that's a little bit more trickier, I would say. Sometimes if you're not too comfortable with analyzing the protocol in a protocol analyzer, it can be a little bit daunting. It certainly was for me when I first started getting into diving deeper into troubleshooting.
Well, you can always call Peter if you're in doubt while doing protocol analysis. I can give you his direct number. Reach out to me after the webinar. He will enjoy it a lot. And then, guys, you can do quick WLAN analysis. So this is a Wi-Fi scan. You're looking into 802.11 packets, mostly beacons, and just by glancing at it, you can very quickly see things that are outstanding, and you can very quickly become a hero. So don't tell everyone or anyone that I've told you, but Ekahau Analyzer will be a little bit more powerful, where you will be able to spot tons of different issues at a simple glance at your screen, plus see the spectrum analysis graph on your mobile device screen, which is, as always, extremely mind-blowing. So you can see data rates, you can see primary and secondary coverage where you are actually right now. You will be able to see a little bit more things. Actually, stay tuned for the a little bit more things, because I don't want to take the fun away from the update that is coming very soon. So WLAN analysis is very powerful for as long as you know what you're looking for and what you're looking at. You can find solutions to problems within minutes after getting to the site, which is what I like. And then Spectrum Analyzer is extremely powerful way to spotting issues with your spectrum, that is both Wi-Fi and non-Wi-Fi. All the interferers, you will be able to see them now, even if you don't see them in packet captures or in WLAN analysis.
Yep. So what we wanted to put together then is, so for, let's say that you're analyzing that, you've done your assessment survey and then you're doing an analysis of that data that you captured, we come up with the 3 C's of troubleshooting for your survey troubleshooting, and that is coverage, capacity, and channel. So when you're looking at coverage, you want to be checking things for primary coverage, secondary coverage, tertiary coverage if you need it, if it's required, with maybe some location analytics that you're looking into or trying to get from your wireless network, and then your signal to noise ratio as well. We're going to dive into a little bit deeper of each one of these categories in a few moments time, but things like capacity can really play a big part in hindering the performance of the Wi-Fi network. If you've got too many client devices trying to associate to the same radio on the same channel at the same time, all trying to do time sensitive applications like voice or video, because typically in Wi-Fi only one device on a channel can transmit at a time, and that's an access point or client devices. And then finally, we want to look at the channel. So how is the channel interference in my environment for my networks and for all of the other networks as well? Because when you're looking at channel interference, sometimes you don't want to just be checking for your own network, because you're also going to be getting interference from all of the other networks around you as well. So it's really important that we look into that. So we're going to cover some theory around channel interference, co-channel interference, adjacent channel interference, primary, secondary, OBSS. So yeah, really looking forward to diving a little bit deeper into that. But Mac, why don't we talk about coverage and a bit more of a detailed aspect?
Cool. Let's start with that. So the most important attribute that you want to review and understand and validate is primary coverage, guys. So I can't emphasize it strongly enough. You need to have primary coverage everywhere where you expect Wi-Fi to work, because without primary coverage, you have no Wi-Fi, as simple as that. It doesn't matter how good your configuration is or how expensive your access points were. If you have no coverage from a device perspective, then you have no Wi-Fi. And now you might ask what device you want to use to check your coverage. First of all, you have your almighty sidekick to very, very accurately check the RSSI everywhere where you walk with your trusted device. But then you have something that we call LCMI, least capable, most important device. It might be a warehouse scanner, or it might be a mobile phone, or it might be a laptop. So it is amazing to understand how sensitive that device is. What is the difference between what Sidekick sees and what the device sees? If you see next 67, for example, at the edge of a cell from a Sidekick perspective, warehouse scanner might drop to next 75 or next 77. Is that acceptable? Is that all right? And it might be, for as long as you understand what you're looking at and what device you're using to validate your coverage, then you're good. And now on the screen, what we see here is it's 3 access points, AP1, AP2, AP3, and we have strongest signal strength. Actually, we did see strongest signal strength from AP2 because it was closest to the device. And yeah, thank you very much, Matt. So we're looking at primary coverage, Matt. What am I looking at? AP2 is the strongest, and that's the primary, neg 59. I thought that you switched to the next slide.
Should we help Mac out here? What we're looking at? He says it's even confusing for Mac. So we've got AP1 that's got a signal strength of -68 dBm, and then we've got AP2 that's got a signal strength of -59 dBm, and then AP3 that's got a signal strength of -72. So the strongest signal that you're getting from the psychic's perspective here is actually from AP2, which is at -59. So when it comes to signal strength, it's the closer that you get to 0 is going to be stronger. So AP2 has its primary coverage here. So sorry for confusing you a little bit there, Mac, but we got there.
That's
in the
cool.
end.
That's cool. Next time I will write slides and I will do the same.
Okay. So one of the things I wanted to think about is what can affect coverage. Now, placement of your access points can really affect the coverage. Like, have you got enough access points to provide the coverage that you need for your design and for your requirements? Have you placed APs too far away from each other so you're not getting the secondary coverage that you need? Or have you got, or even meeting your primary coverage requirements? Because like Mac said, quite simply, if you're not meeting your primary coverage requirements from your device's perspective, then there's simply not going to be any Wi-Fi for them to use. So that's going to be one of the real big things to think about there. So placement of the access points, sometimes they're too close to each other, sometimes they're too far away from each other, or if you just place them in positions where they're surrounded by lots of heavy attenuating materials that you hadn't accounted for, or you wasn't expecting in your design, and you didn't go and validate and do health check surveys to check to see what's changed in the environment, that can really cause problems with your coverage. And then the other thing that can really affect coverage is the transmitting power of the access points. And me and Mac were talking earlier about one of the assessments that we did for one of our customers, and we did an assessment survey, and we saw that the coverage coming from the access points were really low. So we took a look at the configuration, and we noticed that the customer, they had configured the transmitting power range for the access points to be able to use to be very minimal, and also to use a very low power setting for the maximum power. I think it was around like 5 dBm is the maximum transmit power that they could use. So we said to the customer, we said, "Hey, Mr. Customer, how come you've decided to use such a low transmitting power range for your access points?" And he said, I read this really good blog one time, and what it said is that actually if you turn down the power of your access points, it's a really good way to reduce your co-channel interference on your network. So he decided to just take that blog for its word and just turn all of his access points transmitting power down to really low. And what that did to the network basically meant that all of the APs had a very small, great, good coverage coming from the access points, but from the client's perspective, and from the AP's perspective as well, it didn't actually reduce your co-channel interference. It just meant your good coverage got worse. So that meant that you had less good signal, so your signal strength wasn't as strong. If you haven't got a good strong signal, that means you're not going to have a high signal to noise ratio. And with a higher signal to noise ratio means you can have higher MCS rates, but because of having the low transmitting power, they had a lower MCS rate, which meant they could only transmit their data at a lower rate. So it means they were slow on the Wi-Fi. So the actual performance from the client's perspective was worse. So we said, "Hey, Mr. Customer, do you mind just turning up the power of these access points and see what that does to the performance of the Wi-Fi network from the client's perspective?" And he said, "Yeah, sure." So he turned up the power, and lo and behold, the performance of the client devices, they went back up to what they were before. So just watch out for that. Turning down the transmitting power of your access points doesn't necessarily reduce your contention, and it doesn't make the performance of your client devices work much better.
Yeah, and on top of that, it's very important to repeat. If you have excessive contention, very high CCI, cross-channel interference, anything that you do configuration-wise is not going to really, really help you. So we need to take a step back and do a redesign, okay? So CCI, you control it with a correct design, not with correct power necessarily. And about the design, it's not only about the number of access points, number of radios, it's also about the placement of these radios, correct mounting of the access points and antennas, and most importantly, choosing the correct type, of antenna. So typically I'm not sure what these statistics are today, but not long ago, it was 95% of all the access points used were internal omnidirectional antennas built into those APs. And while it's a default choice for a carpeted office space, it might not work too well in the airport or in manufacturing site or in a warehouse where most likely you will see those internal omnis installed there as well. So you really need to make sure that you focus your coverage where your clients are by using correct type of antenna and correct mounting. And that's not only that, the transmitting power level of a radio and a passive gain of a directional antenna, they are just two elements. When you calculate your radiated power, EIRP, you also have to consider the length of a cable and the connectors on that cable between the access point radio and the antenna. You add passive gain, you add the transmitting power levels, and then you detract the cable attenuation and connectors attenuation to calculate the real EIRP of your setup.
Yeah, and I just noticed someone in the chat talking about, what is like a good range to set for your transmitting power, since we were just talking about that. And what I would say here is that you should use the same transmitting power ranges that you did for your design. If you did 14 dBm and to 17 dBm in your design, but then you set your actual configuration for your implementation to be 5 to 11, then the implementation isn't going to match the design. So the range that you should set should be, consistent with what you designed the Wi-Fi network to be. So if you use the lower range, then it's fine. Obviously it'll be, and it works okay, then that'll be fine to use for the implementation. But if you've done your design is using, say that's between 14 to 17, you're going to probably want to set that range to be around that as well. So that was a really good conversation I saw popping up in the chat there. So I just wanted to call that out. And we're going to talk now about something that we refer to as our want area, our don't want area, and our don't care area. Because, when it comes to designing our wireless networks, one of the questions that we get all the time is that, what sort of signal cell edge should we be aiming for? And, we've got this legend inside of Ekahau, how should we be setting that? And the answer here is that it always depends on your design and your requirements. If you're designing for voice and video over Wi-Fi in an enterprise office, it could look like X. But if you're designing for pure basic connectivity inside of a warehouse for some scanners, then it could look like Y. So it always really comes down to your requirements, your client devices, and what you're looking to achieve from the network. But we would say that these values that we've got here are a good baseline that we can kind of look to use and approach. So the reason why we have for our want area in green set at -67 as kind of the threshold for our green signal strength, our want area, this is because typically up to -67 dBm for your primary cell edge, this is going to be the limit for where you'd be able to maintain voice and video calls over Wi-Fi. Yes, it may work at a slightly lower threshold, but you might be noticing some form of connectivity drops and issues there. So that's why we typically set that primary want coverage area in green to be -67. So then what is this threshold then between our want area to our don't want area, where it's -67, but going down to -85 dBm in gray? And we call this the don't want area because this is where the signal from the access point is not necessarily good enough to do the applications and the time sensitive and the things that you want it to do. But when it comes to Wi-Fi, if you have another access point sharing the same channel with another access point on the same channel, and they can hear each other at a threshold of typically around -85 dBm or greater, they will share that channel, and means they've got to play the game nicely with each other, and it'll be AP1's turn to transmit, then AP2, then AP1, and AP2, and they have to share that medium between each other. But we have our don't care area, which is the threshold between -85 to -100 dBm. So if you hear or you're hearing something that below that threshold, you just don't really care because you're going to transmit your frames anyway. So this legend here is completely configurable inside of Ekahau AI Pro. We will point it out to you later on in the demo, and you can make sure that this is what you want to meet your requirements. But these are some really good values as a kind of good recommendation for what you might be wanting to design for.
Exactly the case. And now the secondary coverage, this is extremely often not understood correctly. So what questions I have is like, why do I need to have secondary coverage really? If I have a primary everywhere, is it going to work? And the answer is yes, it will work. But what happens if you lose your primary access points? You have an outage of a switch, a cable breaks, an access point breaks, it happens. You have no redundancy. So secondary coverage is required to have good redundancy. That's the first thing. Another thing is, what happens if you have access point just above your head, but before you were coming to your desk, you were associated to an access point 10 meters further away from you. And even when you are sitting at your desk, you will still associate to the access point farther away from you because the connection quality will be most likely good enough for your device to stay connected to it and enjoy great quality Wi-Fi. That adds more capacity. So by having primary and secondary coverage, you will have more capacity in your network, of course, for as long as you don't have excessive CCI, channel contention. And most importantly, in enterprise environments especially, is fast roaming. So our applications, they are typically voice and video or both, or even in warehouses and manufacturing, I've seen like AR glasses where the system tells you where you have to go inside the aisle to find an item that you're looking for, or you have audio guided instructions about where to go to pick up something. It's all, audio or video, and on top of that, quite low latency. So while walking around your facility, you need to be able to roam, to reassociate between access points very fast. And without a secondary signal, you will not be able to do that. Try to imagine, like, I hope that most of you know what 802.11k is, where it's an amendment where your device can ask the existing access point, Mr. Access Point, what APs do you see in your neighborhood? What channels do I have to scan in order to find next best alternative for me to associate to reassociate to roam to? And if you don't have a secondary coverage, the access points, they actually will not see each other. They won't hear each other. So you won't have the benefit of using 802.11k if you don't have a proper secondary coverage as well. So to reiterate, secondary coverage is required for redundancy on the access points level, for more capacity, and most importantly, for spotless roaming.
So ladies and gentlemen on the webinar, do we think that we need to help Mac realize which AP is given the secondary coverage here? Do you think he knows? He can read it this time? No?
Please go on.
Okay. Well, we've got the 3 access points here, and now AP1 is given a signal strength of -68 dBm, AP2 is given a -55, and then AP3 of -72. So that means that AP1 is going to be providing that secondary coverage now in this example. So there we go for our secondary coverage. So the next thing that we wanted to talk about was capacity, and capacity can be one of these things that has a big impact on our Wi-Fi network. So when we're talking about capacity, we're talking about the amount of devices that we have connected associated to a radio inside of the access point. Now, it's really good to understand that if you've got too many client devices associated to the same radio inside of an access point, then there's a good chance that not all of them are going to be able to do some of the time sensitive applications that they were looking to do. If you've got 200 client devices connected to one radio and an access point, all trying to make and maintain a video over Wi-Fi call, bearing in mind only one device can transmit on a channel at a time, there's a good chance you're going to have a pretty dodgy Wi-Fi connection for your voice or video call over Wi-Fi. So you want to kind of limit that down and really keep in mind how many devices you're going to be having to associate to your radio inside of your access point. And a really good way of being able to control that, Mac was talking about earlier, that example of an airport and using external antennas to control the size of your cells from your access point can be a really good way to kind of control how many devices you're going to be having connecting to your access points. Another big thing to think about and bear in mind is your device capabilities. So this is going to affect your things like your data rate. So if you've got, let's say, a legacy device that only supports maybe it's 802.11a and can only do WPA1 TKIP, this means that the maximum data rate that they're going to be able to use is 54 megabits per second to transmit their data frames. But so what does that mean then? So if you've got old legacy client devices in your network, and they are, they win the game for the contention to the Wi-Fi, they could be sending their data at a much slower rate than some of your other client devices, where they could go much faster and therefore hindering the performance of the Wi-Fi network. So if you've got the low data rates enabled on your Wi-Fi network, this means that client devices, even if they're really far away from the access point, they will still be able to connect and transmit their data frames even at a really low, slow rate. So one good tip here is that you probably want to I saw a good conversation in the chat talking about what sort of data rates do you want to have switched on and enabled, and typically we say that, sorry?
And WAPs.
And WAPs. Yeah, so we're talking about like what sort of like is a kind of, good guide for data rates that we should have enabled. And we say typically if it's a standard density environment, you can't go wrong with just having 12 megabits enabled as your minimum basic rate. Or if it's a very high density deployment, then we kind of look to go around like the 24 megabits per second. But again, make sure you test for in your environment. And then we were talking about earlier about the transmitting power of your access points. When you tune down the transmitting power of your access point and you've got a weaker signal from your access point, it means weaker signal for client device, lower SNR, lower MTS rate, lower data rate, therefore sending their data at a slower rate. So if you're downloading that big Netflix movie or uploading your big file to Dropbox, it's going to take you more time. The other devices, they're going to have to wait their turn, get in line to be able to transmit their data too.
Yeah, and before we switch to channel, extremely quick discussion from the chat about channel utilization and number of clients associated to a single radio. I've seen some comments about a fixed number of clients connected to your radio in order for Wi-Fi to work correctly. And the answer for that is, first of all, it depends on what we want to achieve with our Wi-Fi network. If you want to have spotless voice or video network, you want to have your channel utilization low. Generally, like 20% or 30%. If you have more sustained channel utilization, then you will have drops, you will have a lot of jitter, and you can't have that. Sometimes if you have just data only network and devices used for, I don't know, sensors or email or whatever, you might have more devices doing that at the same time. So it really, really depends. I would focus more on what you want and need from a Wi-Fi network and channel utilization rather than a static number of clients associated to a single Wi-Fi radio. Okay, and now we can switch to channels discussion. Let's start with 2.4 gigahertz. So 2.4 gigahertz is an old band. We've had it forever, right? So we have 3 bands now, 2.45 and now 6 gigahertz as well. 2.4 gigahertz, it gives us around 80 megahertz of usable spectrum depending on the country, but the global standard is around 60 megahertz that we use in non-overlapping channels. So we always use channels 1, 6, and 11, no matter where we go. Even if you can use more, most people around you will use channels 1, 6, and 11. And you don't want, honestly, you don't want to be in a situation when you are using channels 1, 5, 9, and 13, and all of your neighbors are using 1, 6, and 11, because you will not be respecting the contention rules, and you will be shouting on top of each other, creating collisions, retransmissions, and life will be bad. Wi-Fi will be slow. So on 2.4, we not only don't have enough spectrum for modern applications like voice and video, we also have tons of other wireless, not necessarily Wi-Fi devices working in that band. So we have Bluetooth, we have BLE, we have Thread, we have Zigbee, we have all the IoT stuff. We have analog cameras, we have analog phones, you name it, okay? And it all might work on 2.4. And if you have those devices, they will be using quite a lot of airtime, and therefore your Wi-Fi devices, they will defer and they will not have opportunity to use the spectrum. So that's 2.4. We call it a legacy IoT band these days.
So I can't help but laugh. I'm loving the conversation in the chat today. Some great questions coming up, and I can't help but laugh about one of those last comments around WAP. And yeah, careful searching that on YouTube if you're looking for a song about WAP. I think that kind of killed WAP for the Wi-Fi industry, so that's why it's no longer used. But yeah, I couldn't help but laugh. I saw that. You guys are killing me today. So 5 gigahertz then. 5 gigahertz, that gives us about roughly around 500 megahertz of spectrum that we can use, and depending on where you are, we can have up to that 25 or now even up to that 20 megahertz wide channels, which is amazing, which is great. We've got loads of spectrum we can use there. But with 5 gigahertz, there's a few things that we have to take into consideration. First thing with the 5 gigahertz channels is that only some of them are not affected by something that's called DFS or radar activity, which is the Uni 1 band and the Uni 3 band. So if you're in an environment and you're using the Uni 2 channels and your access points detect that there has been radar activity, Wi-Fi isn't the priority here. You've got to protect these incumbents for DFS radar activity. So if you've got, let's say, an access point working on channel 100 where you've got 10 client devices associated and a few of them are on a voice call, and all of a sudden the access point detects there's radar activity, they have to move and go on to another channel. Then your client devices go, what do I do? Do I follow this access point onto the new channel, or do I, look for another access point to go and associate to? Have you got enough secondary coverage in your environment to go and find that other access point to go and associate to? But bear in mind, going through all of this process, you're on a voice call, time sensitive call. Your call's probably now dropped. You're missing some of the conversation that's happening, a bit like that. So it's one of the things that you've got to watch out for with when it comes to 5 gigahertz, different transmitting powers for different regulatory domains where you are as well, for indoor versus outdoor. And also as well with 5 gigahertz, and in 2.4, you can bond 2 channels together to get that to go from a 20 megahertz wide channel to a 40 megahertz wide channel that will give you faster data rates, which is, great, but you have to think about some other things as well, especially when it comes to 5 gigahertz. We can go from 40 megahertz wide channels to 80 megahertz wide channels and up to 160 megahertz wide channels. But we have to pay a little bit of a consequence for bonding those channels together, because every time you double the channel, you double the amount of noise that you're bringing in. So you could be getting impacted by a lower SNR value and again lower MCS rates. But it's actually something else that we wanted to quickly talk about that can really impact your Wi-Fi network on 5 gigahertz, which is something called primary secondary OBSS. But I'm going to let Mac explain that on this slide now.
Thank you very much, my love. So let's talk about the primary secondary OBSS. And guys, this is real and this is serious, and it can really affect the performance of your Wi-Fi network without you realizing it too much. So first, on this slide, everything is fine, okay? We have either 20 megahertz channels and BSS1. So BSS, it stands for basic service set. So one access point with radios and clients associated to that AP. And then BSS2 will be like another radio with clients associated to that on a different channel, hopefully. So we have 36 and 48, quite a lot of spectrum separation between those two. Life is good, everything is fine. Then if you want to start bonding channels together to have 40 megahertz, so 40 megahertz in 5 gigs will give us higher data rates, MCS rates, hopefully, but also be careful that SNR will go 3 dBs down every time we double the channel width, okay? It's no longer the case in 6 gigs though. So here, even on 40 megahertz, we still have 2 non-overlapping channels in this beautiful Uni1 on 5 gigs. Now, switch to the next slide, Matt, please. And what you can see here is that we have BSS1, so access point 1, first radio, it's on channel 36, and it's a primary channel, whereas BSS2, second access point, they are still overlapped somehow. The clients, they can hear each other. It has channel 40 being its primary channel, and both of these APs, both of these BSSs, they are using channel 38. 38, it means that we have bonded channels 36 plus 40. So you might think that we have a CCI, but it's not entirely true. We have CCI as well, that is true. So we can detect the energy between 2 different BSSs, but we cannot detect the preambles anymore. So in order for you to understand it, we have to understand what a primary channel is. And the primary channel is a channel, primary channel in a bonded channel that is used to transmit all the management and control traffic, and also all your Wi-Fi devices. Before they speak, they listen, and they will listen on the primary channel as well. They will have a CCA, clear channel assessment test, done on a primary channel. So for example, in here, if you have clients in BSS1 actively transmitting something on channel 38 at 40 megahertz, it's channel 36 primary plus 40, so it's 38 at 40 megahertz, it's transmitting. And now at the same time, you have a client in BSS2 wanting to transmit, it will listen for preamble on channel 40. Oh, is anyone out there transmitting Wi-Fi stuff? And it will conclude that there is no one talking Wi-Fi. So it will start talking on channel 40 plus 36 for data on top of BSS1, and both clients will be transmitting at the same time. So what is going to happen is a massive collision. They will not have acknowledgements for their transmissions. They will have to go back, wait for another backup timer, longer this time, and then they will have to retransmit data again, hoping not to have a collision again. So they will be shouting on top of each other very often, collisions, retransmissions, and your Wi-Fi will be terribly slow. This is worse than ACI, this is worse than CCI. So be mindful of that. And on 5 gigs, always use the first channel to be your primary channel, or at least try to match what your neighbors do. That's it.
Yes. And now we have the addition of 6 gigahertz. So depending on where you are in the world, you might be getting an additional 1.2 gigahertz of spectrum that you can use, which will be the equivalent if you're using what's called the low power indoor, because we have some different things we have to think about with 6 gigahertz around power constraints. So we have low power indoor, standard power as well. But with LPI, that gives you up to 59 20 megahertz wide channels. But we have the standard power as well. So let me just bring up standard power. So depending on where you are, so if you're like us in Europe, we're only getting 500 megahertz of additional spectrum, which is still great to get some additional spectrum. But things we need to think about a little bit more when it comes to 6 gigahertz now is like, how are our client devices going to discover these 6 gigahertz radios? This could be playing a bit of an impact. Low power indoor for the access points and client devices that are going to be inside. So yeah, standard power can be used for, you know, external antennas and going to be coming in, but that's only going to give you 41 20 megahertz wide channels depending on where you are. We have done quite a few good deep dives onto 6 gigahertz. We're not going to dive too deep right now, so if you want to go back and check out some of the other previous webinars on 6 gigahertz, plus we have some more coming up as well. But the big thing we just wanted to call out here when it comes to troubleshooting for 6 gigahertz network is we think that the most likely method is going to be the preferred scanning channels for discovering your access points and radios on 6 gigahertz. So if your deployment isn't using the preferred scanning channels, then some of your client devices could potentially be having some issues with finding the 6 gigahertz radio. So that's something to keep in mind. But let's quickly talk about some other things that cause some problems on Wi-Fi. Then we're going to jump into a demo.
Of course. So, you know, Wi-Fi is just Wi-Fi, but you might have other wireless devices operating in the same Wi-Fi space. And it's crucial for us to be able to detect those devices. Both sidekicks can do it amazingly. And the impact on duty cycle that those devices they inject into our spectrum that might affect Wi-Fi might be huge. So if you have something that is taking all the airtime all the time, your Wi-Fi on that particular frequency will just not work. Okay, so we have to be mindful of that. And let's take a look at the demo where Matthew will talk us through the interesting stuff.
Hey, why don't we analyze some survey data together inside of this Ekahau project file? Now, the very first thing that I like to do is to check to make sure what coverage requirements we've got set for this file, so we know what we want the criteria of the Wi-Fi network to meet. So to do that, I'm going to head up to here where it says project and then select coverage requirements. And now this is where we're going to be able to see which coverage requirement we've got set and the different values for each of the criteria. So on the left-hand side, we've got our criteria, everything from our primary coverage, secondary coverage, down to signal to noise ratio, data rate, channel interference, etc, etc. And then we can see on the right hand side we've got the 3 different frequency bands, so 2.4, 5 and 6 gigahertz. And then we can see the requirement values that have been set for that specific criteria for that specific band, so we know what we're looking to achieve from the Wi-Fi network based on these requirements, which is fantastic. I can see what we are looking to do now, so I'm going to simply hit close. Then the next thing that I want to do if I'm analyzing a file that has been sent to me to review is I'm going to check to make sure that that coverage requirement profile is actually set inside of that area. So to do that, I'm simply going to click on the area, then go and hit advanced, and I can see that the coverage profile is that Ekahau best practices, the same one that we had inside of that coverage requirement that we were just looking at 1 moment ago. The next thing that we can see here is the devices that have been assigned inside of this area. So what devices are going to be being used on the Wi-Fi network, how many, and what SLA do they need? So what applications and bandwidth requirements are they going to need? And we can see that we've got some Wi-Fi 6E devices here, or Wi-Fi 6 in 2.4 and 5 gigahertz. So even though we've got no access points on this wireless network that are 6 gigahertz capable, even though there are some 6 gigahertz clients here, that means that on 2.4 and 5 gigahertz, they're going to be using Wi-Fi 6. So I'm happy to keep it like that for now, even though we've got no 6 gigahertz APs that we validated on this validation survey. So let me just close that. So why don't we use that method that we spoke about earlier on with the 3 C's and checking for coverage, channel, and then capacity. So what I would like to do is I like to go by the bands first of all. So why don't we go through the 2.4 gigahertz first, and then we can take a look at 5 gigahertz. So what I'm going to do now is let's check for coverage on 2.4 gigahertz. So what I'm going to do is I'm going to change this visualization now from empty to the signal strength view. Okay, and what it's going to show us now is the signal strength that we can see on the 2.4 gigahertz network. I remember earlier we was talking about our want area, our don't want area, and then don't care. So that is completely configurable from this legend that we see right here. But what it's doing is actually pulling the information from that coverage requirement profile, and it will adapt and change your visualization legend right here. So what we're looking at now is the 2.4 gigahertz coverage. But one thing that I want to point out right now is actually we're looking at the signal strength for this floor plan for 2.4, but it says that we're looking at all measured. And if I'm checking the coverage requirements, I want to check the coverage requirements from the access points that are being used from the stakeholder or the customer that I'm doing the validation for. So to do that, what I want to change this to now, rather than being all measured, I'm going to change this to be either all my networks, which are the networks that have been starred for all of the Ekahau SSIDs we can see here, or the marked access points. So they have been marked with a color, which is orange. So you could either filter now by looking at all my networks, or I could select the orange filter and it's going to just show me the coverage coming from these access points. What I'm going to do now is I'm going to select all my networks, and what we can see right now is that on 2.4 gigahertz, we only have a small area of the office being covered from 2.4 gigahertz. And if I take a look at what channels are being used on the access points, I can see actually out of all of the access points, only 2 of them have got their 2.4 gigahertz radio enabled. So here we can see channel 6 here and channel 11 here. So if we needed to provide 2.4 gigahertz coverage throughout the whole office, we can see that there's not enough primary coverage throughout the whole office because most of the access points, they haven't got their 2.4 radios enabled. So let's see what's going on. If I now go to the inspect tab, and if I click my mouse in a position on this floor plan, I can see on 2.4 here, we have actually got a couple of these access points broadcasting a 2.4 SSID, which is called Ekahau IoT. So it seems that we're trying to provide some 2.4 gigahertz coverage for these IoT devices that could be using 2.4 gigahertz. But if we're only using, 2.4 in this area, it's probably going to be okay. But if you wanted to provide some coverage for these IoT devices throughout the rest of the office, then I think we're probably going to need to switch on a couple more radios. So why don't we take a look at the secondary coverage for this validation file on 2.4. So to do that, I'm going to select here and change it to the secondary signal strength. And yeah. So yeah, not too shocking that we are not quite meeting our secondary coverage requirements, considering we've only got 2 of the access points here with their 2.4 gigahertz radios enabled. So yeah, if we wanted to provide some more primary and secondary coverage, I think we're going to need to switch on a few more radios on these access points on this deployment. So that's the first C for 2.4 gigahertz coverage. We're not quite meeting it. Well, why don't we check the channel now? So if I want to check to see how much channel interference we've got on 2.4 gigahertz, what I can do now is select the channel interference visualization. So coming over here and select channel interference. And what you can see now is it's gone green. So that means that we haven't got any channel interference on 2.4 gigahertz over here, because we can see one access point on channel 6 and then the other access points on channel 11. But when we are checking our assessment file, our health check file, validation file, whatever it is, when we are looking for things like channel interference, do you think that we just want to be checking our own access points for channel interference, or do we actually want to look at the whole environment and all of the access points that we can hear to check to see if we've got channel interference? And well, yes, we do actually want to check all the access points that we can hear. So I'm going to change this now to all measured, and it will bring back those access points that we saw from earlier. And what you can see now, it kind of paints a slightly different picture on 2.4 gigahertz, because what that means now is, because we are now looking at all of the access points on 2.4 gigahertz, then now we have got more channel interference. And because it's not only our own access points we interfere with if we are on the same channel or sharing the same channel, it's everybody. If we can hear another access point transmitting on the same channel, that we will play the game nicely with them and not transmit over them. So it's good to check to make sure we're not interfering with all of our neighboring access points as well when we're checking for channel interference. So why don't we take a look at the next C, which is capacity, and see how our capacity is performing on 2.4 gigahertz. So I'm going to do that. I'm going to change to this view now, which is called capacity health. And then what you're going to see in a moment's time is some pass or fail if we're meeting our requirements. And we can see for on this side on 2.4 gigahertz around by this access point, it's all green, but over here on channel 11 we don't see anything here, which is a little bit strange. I kind of wonder why that might be. So what I want to do now actually is let's see if we can find anything untoward that's going on. So what I'm going to do is I'm going to zoom into one of the data points on this survey file and select it to see if we can find out what's going on. If we take a look on this spectrum over here, we can see that there's an interfering device on 2.4 gigahertz. So if I just take a little bit of a zoom in, we can see that around channel 11 there's a video camera. And if a video camera, a non-Wi-Fi device, a layer 1 interferer is constantly transmitting, this means that this access point here that's trying to use channel 11 as well, because our access points have to play the game nicely too and check to make sure there's no other Wi-Fi devices or non-Wi-Fi devices trying to use the same channel that it's trying to use before it can even send its beacons out on its radio of the access point, or if it wants to, you know, send some data to a client device. It has to check to make sure that the medium is free. And because we've got a interferer here, it's not getting that opportunity to be able to do it because this is constantly transmitting. So actually, let me just zoom back out again. And what a visualization we can look at is actually something that's called interferers. So I'm going to change to that, and I'm going to turn on this view at the top called interferers as well. So I'm going to select interferers. And what you can see is that actually Ekahau automatically detected some of these interfering devices on the wireless network and places them for us on the map the same as our access point. So we can see that we've actually got a couple of 2.4 gigahertz video cameras operating in this area, which will be causing a bit of a problem for us on our 2.4 wireless network. So that's why it was not looking quite right for that access point in channel 11, because of this device that was here that we need to remove so we can then have the Wi-Fi network back working on 2.4 gigahertz. So we've had a quick look at 2.4 now. Why don't we take a look at 5 gigahertz? So I'm just going to go back to here, zoom out, and I can see that we've got we'll have no interferers on 5 gigahertz. So what I'll do is I'll just remove that from the view now to make it a little bit easier to see what's going on. Okay, so now we're looking at the 5 gigahertz right now for our access points. And what I want to do is let's check the coverage from our access points. So I'm going to go back to the primary coverage, look at our signal strength, and you know, I can see pretty much everywhere our signal strength is okay. But oh no, actually what I'm looking at right now is still the all measured. So what I want to do now is go back to just filtering and looking at my access points to make sure our access points are meeting the coverage requirements for our network. So I'm going to filter this back down to my networks. We can see that they've been removed now, and we're going to be looking at the visualization for our access points that we've got here. Okay, so we're happy that we're meeting our primary coverage. How about our secondary coverage? So I'm going to flip to the secondary coverage, and yep, I can see everywhere is meeting our secondary coverage requirements. Perfect. So that's our first C. Now let's move on to the second C for channel. So let's do that again. Come over here and let's look at the channel interference. And oh no, we can see that, you know, in a few areas, even just on our own access points, we have got some channel interference. So over here, we've got 2 access points sharing the same channel on channel 60, which is causing some channel interference here. But if I look at what's going on over here, we've got one access point down here that's using channel 100, and it's got an @ symbol and a 40. So that means that this radio inside this access point is using a 40 megahertz wide channel on channel 100. And then we've got an access point here that's using channel 104 by a 20 megahertz wide channel because it hasn't got that @ symbol followed by another number. But then why is this a problem? Because this is using channel 100 and then this one is using channel 104. And well, why is this a problem is because this is using a bonded channel, 2 20 megahertz wires put together at 40 megahertz for channel 100. So that means it's going to be overlapping with channel 104. So we can actually take a look at that if we have a little peek into the spectrum. So I'm just going to zoom in here, select this point, and what you can see if I zoom in over here as well into this part of the spectrum, you can see that we have got the access point that is on channel 100 taking up 2 channels. And we've got one access point here on channel 104 that's just taking up that 20 megahertz wide channel. So why is that a problem? So we were talking about earlier on 5 gigahertz, we have this primary and secondary OBSS issue, because what that means is that we've got this access point here that's using channel 100 as its primary channel for the 40 megahertz wide channels that it's using. And then this access point here that's on channel 104 is using a single 20 megahertz wide channel. But when this conference large on channel 100 is checking to see if the medium is clear, if it can detect any other Wi-Fi radios or access points on that same channel, it checks on channel 100 to see that. So not a secondary channel, which is on channel 104, where this workshop AP is on channel 104. So this will be causing us some primary, secondary OBSS issues in this area, which we would probably look to rectify, because this could be causing us some issues on our wireless network. But again, at the moment, we're only filtered on just our access points that are here. What we would really need to do is take a peek into what's going on for all of the access points in this environment. So switch to all measured, and what do we see here? We can see that, you know, it didn't change too much when we take into consideration all of the other access points that we can hear around this building. So they're not necessarily using the same sort of channels as what we are for our environment. Okay. So I'm going to go back to just our networks, and then let's take a look at the capacity health now. So on 5 gigahertz. And what you can see now is that actually, based on the requirements we have got set inside of our area, those devices and the SLA that we've assigned to it, actually we're not meeting our requirements because we have got multiple access points sharing the same channel in this environment. And too many devices all trying to access the medium at the same time based on the SLA that we've got configured. And you can see we are simply failing because we've not got enough airtime. And yeah, we can see that we've got a nice chart here that shows us that. So what could we do to fix this issue? And I'm going to head back over to the design tab now, because we just learned before that, you know, we've got 2 access points down here that are causing that primary, secondary OBSS channel interference. And we've got 2 access points here sharing the same channel on channel 60. I wonder if we could run a new channel plan for these access points that are currently deployed to see if this would actually fix our capacity health issues. And we can do that on a validation file that we have got here. So what I'm going to do is I'm going to come over to underneath the design tab and select this button right here, which is our channel planner. And when I select that, we can now do a channel planner where Ekahau will come up with a new channel plan for our access points that we have measured to see if that would improve the performance of the wireless network. So for now, we can choose what frequency bands, and let's just say that we are looking at the 2.4 and 5 gigahertz for now. So I'm going to select that 2.4. I'm going to stick to just channels 1, 6 and 11. That's fine. And then on 5 gigahertz, we can select which channels we want to use. If there's any that, you know, we needed to not select because some of our client devices don't support some of these channels, or we've got some DFS radar activity, you can simply uncheck one of these channels or however many channels that you want to remove from your deployment or your design. So the next option we have here is to select if we want to use a 20 megahertz wired channel, a 40 megahertz wired channel, 80 or 160. So I'm going to leave it at 20. And then what I'm going to do is simply hit create. And what Ekahau is going to do is going to do a channel plan on our deployed access points that we've got right now, and then see if that meets our requirements. And yeah, so channel interference is still passing for 2.4 and 5 gigahertz because we've just got these 2 access points down here on 2.4 gigahertz, and it's changed all of our 5 gigahertz radios, including this one that was on 40 megahertz wide, to be down to 20 megahertz wide only. But what we can see here is that we're actually still failing our capacity with using a 20 megahertz wide channel deployment based on the requirements that we have set. So why don't we try running the channel planner again? But this time, let's select the 40 megahertz wide channel and see what happens. So I'm going to simply hit create, and we're going to run a new plan again. And all of a sudden now, all of our access points on this deployment are using 40 megahertz wide channels, and none of them are creating that primary, secondary OBSS with each other. And our capacity requirements are now being passed and being met from using a 40 megahertz wide channel plan. But when you make a change to the channels in the environment, and especially if you're going to start to use bonded channels, one thing that we should go back and check is our channel interference to make sure we've not introduced any unnecessary co-channel or co-channel interference or excessive channel interference on our own network. And we can take a look at that now, and we can see that, you know, with this new channel plan, we are meeting our requirements. So that's just a few ways that we can analyze some survey data, going through our 3Cs, checking for coverage, channel, and capacity. And you know what, it's really cool that we can actually run the channel planner and fix some of those issues that we were having from this file. So that's really cool. So anyway, back over to you, Matt.
Okay, thank you very much, Matt, for an interesting demo. I just wanted to reiterate a few of those things that we have just said in like a very simple table. I hope you guys are right with running over by like, I don't know, like 3 more minutes to go through the content. I will not spend too much time on this, so grab a screenshot of it or wait for the recording. But based on around 500 surveys that we've done between Matt and I, these are the top 5 issues that we see in the Wi-Fi world. So, and of course the resolutions. So first is excessive CCI. It's a hardcore contention, CCI, ACI, primary, secondary, OBSS, whatever. And a typical resolution for it is to reduce channel width or redesign, because you need to start there. Without the correct design, no matter what you do, you won't have a perfect network. And if your design is perfect and you still have massive CCI, then talk to your neighbors, okay? Because they might be killing all the fun. Issue number 2 is poor coverage, and that's typically due to bad design. So redesign, use correct antennas or add more access points, but still it's a balance art. You don't want to have too many radios because your CCI will go through the roof. Third thing is slow roaming. So you might expect your Wi-Fi to give you voice and video capabilities, but when you walk around the office on a call, you drop off. And the biggest things that can affect roaming is secondary coverage. It must be rock solid. Today, you pretty much design secondary coverage to be as strong as a primary one. And you have to use amendments. 802.11k is extremely important, the most important out of all of them. And if you are using .1x authentication, then you also want to use 802.11r. So you don't have to talk to the radios in the backend every time you roam between APs. And additionally, you must ensure that all your clients, they support all those amendments. Issue number 4 is poor performance. And poor performance, it's typically due to high contention, so issue number 1, and too low capacity. You might need to have more radios. Be careful with that CCI. Your minimum basic data rates might be too low. So all your management control traffic beacons might be eating up a lot of airtime. And if you have too many SSIDs, that will not help because you will have more beacons in the air. And too many SSIDs at low basic data rates, that might be a network killer completely. Your airtime might be 100% all the time, even without users traffic. Be careful. And also you might have interference outside of your Wi-Fi network. So be careful with that. And the last issue that we see extremely often is devices simply won't connect. And that happens if they don't support any of the amendments enabled on your radio, or if you buy some new fancy AP supporting new fancy things and you enable, let's say, WPA3 on 6 gigahertz band, and then 5 gigahertz band can also support WPA3. So you enable that, and then you realize that none of your clients can connect because they simply don't support WPA3. Happens very often these days. And that's pretty much it. That's a cheat sheet that is summarizing everything that we have said in this webinar.
Yeah, and I'm not sure if you can tell, but we get a little bit excited when we talk about troubleshooting and Wi-Fi. And this was really just scratching the surface, the very tip of the iceberg. We've only had 1 hour and we still couldn't cover so many things that we'd love to discuss with you with troubleshooting. But if you have enjoyed this, then we have got a brand new ECSC troubleshooting course that is now available and will be being taught from this month onwards, which is super, super exciting. So if you've really enjoyed this webinar, then you're dying to get some more troubleshooting tips and tricks and really understand how Wi-Fi works and what to look out for. And we even have an amazing troubleshooting checklist that we give away on the ECSC troubleshooting course. So go and scan that QR code and you can get yourself signed up for an upcoming troubleshooting course, which would be, it's an amazing, amazing class. Really excited for this one. So make sure you check that out. And also something else very new with ECSC, Mac.
It's recertification course, and this is a big deal, at least for us. I hope that it's a big deal for you as well, my friends, because we've spent tons of time and put our hearts in creating 5 hours worth of content. It's a video on demand content that is extremely useful and practical. It's not dry. So if you've sat your ECSC a few years ago and you want to see what's changed not only on the market when it comes to addition of a new band, perhaps, but also in Ekahau, in our tools. This will be a great refresher for you, and it will fill in the gaps in between your course a few years ago and how the situation looks like today. It's really, really, really good content. I hope you will enjoy it as much as we enjoyed creating it.
Yeah, so just a few things to clear up here. You can renew your ECSC certification status if you've already attended, let's say, an ECSC design class. If you attend our new ECSC troubleshooting class or the advanced class, that will renew your credentials for 3 years. But if you've got an expiring ECSC and you want to take this course, no matter what ECSC you currently hold, if it's design in advance or design advanced troubleshooting, if you attend and pass this course, we will renew all of your ECSC certifications as well. And one of the other really amazing things we do here at Ekahau is we actually give away free attendance to an ECSC design class if you sign up for our ECSC scholarship program. So we just want to say a massive congratulations to Matt Smith and Cody Insanian. I hope I said that okay. If you would like to know a bit more about our ECSC scholarship program and sign up for it, then please head over to that URL and you will be able to find out more and then submit your application. You may be one of the lucky winners and get yourselves on a seat for an upcoming ECSC design class. And that, my friends, ladies and gentlemen, brings us to the end of the webinar. We are so sorry that we took you over by an extra few minutes today, but hopefully you enjoyed the content. We love talking to you about it. We could maybe take one quick question because I know people have probably got to jump. But hey, Stu, you got a quick question for us for the Q&A?
I did. Let me go back up onto the top here. I think this one is probably, you know, we talk about that. You're talking about that kind of design scenarios. You know, what is this one came up and we might have answered it too early, but what is the accepted, you know, interference level percentage for 5 gigahertz band? I got a good idea, but I want to kind of hear your thoughts on that one.
Yeah, so let me just try and unpack that. The accepted percentage level for the 5 gigahertz band. So it's kind of, we don't really talk about an accepted level for percentage of interference normally. So if we're talking about like co-channel interference on 5 gigahertz, we might be saying that, do we just want to allow one device on the same channel, 2 devices, 3 devices, 4 devices, 5 devices? When you're talking about a percentage, you may be talking about what is the percentage of channel utilization that would be acceptable in the 5 gigahertz band. And I think Mac answered that question quite well earlier when you were talking about, let's say, if you've got voice or video need requirements for your Wi-Fi environment on, let's say, 5 gigahertz. If you're exceeding over 20% consistent channel utilization on 5 gigahertz, then you may even struggle for your devices to make and maintain voice or video calls. But if they're just trying to transmit and send data only frames, check emails, web browsing, then that's probably going to be okay. When it comes to an acceptable amount of CCI or channel interference or primary overlapping basic service set, you always want to try and have it as minimal as possible. So to try and keep that to a lower number as possible. But in some situations, you just can't help but have some CCI. And it's always better to have signal strength coverage and CCI rather than no CCI, but no coverage as well. So try and keep it as low as possible. We can't tell you a magic number, say, oh, by the way, guys, 3 is a magic number. If you've got 3 CCI, your 5 gigahertz network is going to be amazing. It's going to work and perform exactly how you want it to every time. There isn't quite the magic number for that. But what we would say is that always try and keep it as low as possible, and that's going to give you the best chance of having a high performing wireless network.
And there is more, slightly more, if I may. So let's say that you have an interferer that takes 100% of the airtime, okay? It like blasts the network with a constant video feed. It's an interference, 100%, okay? And how is this going to affect your Wi-Fi? And the answer is, as always, Sam's style, it depends, okay? If your devices that want to transmit data, they hear it with a high amplitude, higher SSI, then they will defer. They will keep on deferring. They will never send anything on that channel. But if you are far away from this interferer that takes 100% of the airtime, and you hear it with less than around neg 62 energy detect threshold in CCA, around that, it might differ depending on the noise flow, then you will just ignore it and still send your data over that noise. I hope that this clarifies things a bit.
All right, well, I think we've taken up quite enough of your time today. Apologies if we ran over again, but again, I hope you enjoyed the show, the content. If you really like the troubleshooting topic, then by all means, please go and check out our new ECSE troubleshooting course, where we can spend 4 days talking to you about troubleshooting Wi-Fi networks. It's really a great topic we love to talk about. But yeah, just want to say a huge thank you to everyone that has joined us on the webinar today. We love having you here and talking about all of these amazing Wi-Fi topics with you. Thank you so much, Mac and Stu, and the rest of the Ekahau team. We will look forward to seeing you on the next webinar in 2 weeks' time. So make sure you get yourself registered for it when it comes out, and we will see you on the next show. So very good day to you wherever you are.
Thank you very much, guys. It's an honor to have you. Without you, there is no us. Thanks for being here.
Yeah. Thank you, guys.
Keep those questions coming. We love them.
Yeah,
great to see a lot of design questions today. So
the chat and the Q&A was great today. I was loving reading it. So yeah, keep it flowing. We love seeing it. Love seeing all your interactions. So yeah, all right. We're gonna end it now, but watch out for the recording. It'll be coming to you as soon as we can get it up onto as fast as YouTube. So yeah, see you later, everybody.
Bye.